on this video, what I wanted to do was kind of explain the last couple questions that were on your Desmos activity, and then talk about another couple problems related to this concept. So on this example here, they talked about Kelly's shape there on the left had an area of 17 square millimeters. Now, obviously, this is an irregular shape here, so we can't just use a formula or anything like that to find the area of that enlarged shape. But we do know that the enlarged shape had a zoom factor or a linear scale factor of 5. So they want to know, well, what's this new area going to be? All right, well, in order to answer this question, we have to know about a couple things. First of all, when we talk about linear scale factor, that's what we've been referring to as the zoom factor before. So in other words, it's what we multiply each side length by on a figure. But again, this is an irregular shape. So technically I don't have sides there, but if I thought about a portion of our whatever shape this is, and then I looked at that exact same portion on the enlarged part, I know I'm multiplying that by 5. If I actually took a piece of string and saw how long it was, it would be 5 times as long. Now, how do I use that to help me find area, though? Well, if you remember on some of the results that you got, if I said the scale factor, and a lot of times the scale factor will be labeled with the letter R. If I have a linear scale factor of R, then when I start comparing areas, I don't just multiply by R, but I multiply by R squared. So for this example here, since I know that the linear scale factor is 5, that means in order to find the area of my enlarged shape, I have to take that original one and not just multiply it by 5, but multiply it by 5 squared. So for this example, I'm going to take 17, I'm going to multiply by 25. And I find out that the enlarged figure is going to have an area of 425 square millimeters. So we took the linear scale factor of 5, we squared that, and that's what we multiplied the area by. All right, let's see on this next figure. This time, again, we know that the shapes are similar. They want to know, though, a couple things. They want to know what's the linear scale factor, and then they want to know what's the area of that smaller figure. All right, well, let's start with the linear scale factor. Again, it's kind of an irregular shape, but they did tell me that the length here was 10, the length here was 40. So I know that my scale factor here is going to be 4. So our linear scale factor is 4 because we multiply by 4 to get to that new length. Which means whatever this area is here, we need to multiply it by 4 squared in order to get the new area, which they said was 656. So really we're taking some value times 4 squared, or 16, and ending up with 656, which means whatever that value is, I can find it by dividing by the 4 squared, or the 16. And when I take 656 divided by 16, I find out the original shape had an area of 41 units, or square units. So just a variation of what you did on that first problem. So again, those are the last 2 problems on the Desmos activity. Let's say I had this problem here. So Jesse looks at the 2 figures. It says at the right, the 2 figures below. And she wonders if they are actually similar or not. So we're going to try to decide, is there enough information to determine if the shapes are similar, and then justify our conclusion. So why don't you guys pause the video and think about, all right, what do I think here? Is there enough information to decide if they're similar or not? All right, well, let's check and see what you came up with here. Well, if these are really similar, a couple things should be happening. First of all, there should be some sort of zoom factor. Well, if they really are similar figures, my zoom factor for this one must have been multiplied by 3. Or in other words, I have a linear scale factor that's going to be equal to 3. So that would be the first thing, is just trying to figure out, okay, well, what is my linear scale factor? All right, from there, the second thing that I'm going to try to figure out is, all right, well, if the linear scale factor is 3, then does the results of our areas match up as well? So if I looked at my areas, I've gone from 40 to 360, which means I multiplied by 9, which is really the 3 squared. So at first glance, it looks like that, yeah, these two things are similar to one another. However, do we really know that based on just the information that I have? Well, the answer is no. We might be close because we do have these two facts here, but what we need to know is we need to know, okay, what about some of these other sides? Or maybe I need to know, what about those angles? So yeah, to get from 7 to 21, I multiplied by 3, but is that happening for each of those sides? And without some other information, I can't make that conclusion. Now, if they've given me some other information, maybe they said, okay, this is 10 and this is 30, then maybe I could go ahead and make the conclusion if I knew about some other sides. But we need a little bit more information on that one. For instance, if I gave you a rectangle and it had sides of 2 and 10, so it had an area of 20. I gave you another rectangle and it had sides of, say, 4, and I didn't know the other side, but maybe I was told that, or actually, let's backtrack here. Let's say all I was given was that side of 2, and I knew the area was 20, and then I knew this side was 4, and I was told that the area was 80. Well, if I went back to this here, I'm not guaranteed that things are going to match up the same way. Because again, I need to know, was it proportional in each of my different pieces that I have here. Okay, so just be careful as you're doing those.